Calabi-Yau manifold. Okay? But you see, by looking at the picture, you realize, at least you realize one thing. The classical Euclidean geometry, if you want to study geometry, then at least the classical geometry, the Euclidean geometry is too primitive to study. Okay? This is a much more complicated objects for us to study. So what should we do? Okay, so how to study high-dimensional geometric object. So our goal, our aim is to study the geometry. Okay? For example, we want to know the volume of the Calabi-Yau manifold. We want to know certain area of it, and so on. Okay? How to study it? We cannot use Euclidean geometry. Instead, we probably have to use all the mathematics we know to detect it, to study it. So we will use calculus, or in the more advanced form, we use, okay, these are technical words. PDE refers to partial differential equations, functional analysis, or complex analysis. We will also use linear algebra, or the more advanced form of linear algebra, Lie algebra, commutative algebra, algebraic topology, and so on, to study those. Okay, so we do teach the basic stuff, calculus, linear algebra, those important mathematics to our undergraduate students. And we teach those PDE, functional analysis, those advanced topics to our PhD students to train them to study geometry. Well, other than that, probably we need to use all the other, whatever results we have in mathematics to study the geometry. Okay, so so that's why this explains that if we want to study high-dimensional object, we probably have to go indirect because we cannot imagine what it is. So after all, Euclidean geometry is too primitive to study. So direct method won't work, basically. All right, so this is probably a simpler example to illustrate what I want to say. So last year, Professor Arnold Bath gave the breakfast lecture, and he is an expert in black holes. So this is an oversimplified version of studying the black holes. So from mathematics point of view, a black hole is nothing but a singularity, just a point. Okay? So when we say there's a black hole there, I mean that on this screen there's a hole from geometric point of view. Okay? So if we cannot go too close to that hole to see that, what should we do? Yes?
We go around the hole?
Yes, you're right.
Orbit the hole.
Yes, you're right. You're right.
See the hole, but
Yeah.
we're not going into it.
Yes, you're absolutely correct. Okay, so how to study it around the hole? Okay, so this is every of our freshman or sophomore year students know how to do these integrations. And the point is that if we cannot go too close to the black hole, because if you do, then you will fall into the black hole, right? So you can only go around it. But the point is, if you do calculus around this black hole, then you will get some result. This tells you that integration of this integrand is equal to 1, which tells you that exactly is that there's a hole there. The fact that it's equal to 1 means there's a hole. Okay? So this tells us the deep relation between calculus and geometry. So when I say there's a hole there, this is a statement in geometry. And when I do these integrations, obviously this is calculus. And the calculus is linked to geometry, or what we say topology, in the following sense. If there's one hole, the integration will give you 1. And if there are 2 holes, of course you need to change the integrand a little bit, but then you will get answer 2. And if there's no holes, the integrations it will give you 0. Okay? So this again tells us that we can study geometry through the study of calculus. Or more generally, we can use indirect method. We can use linear algebra, use calculus, use everything to study geometry. So this is a simple example. And the conclusion is that So since our human beings can't imagine or sense any high-dimensional object, but those high-dimensional objects are necessary, are useful for us to study, so then we have to go indirectly. So mathematicians never go something indirectly without a purpose, unless we have to do that. So in this sense, mathematics is the seventh sense organ. So we can use that. We can detect, we can imagine, we can study high-dimensional objects.